All right, so we got to this example here, number 16, right? The table below, so we didn't finish this lesson, we'll finish this up now. Shows the number of hours spent studying for a final exam. Eager Beaver over here with 5 hours of studying. Who gets a 94? Of course, guys, this is not always true, right? Somebody who spends 0 hours doesn't always get the lowest grade, right? But anyways, find the average rate of change on the interval 1.5 to 4, right? So, I had somebody who stayed after yesterday, and they're like, I don't get these questions. What does this even mean? Guys, what are these values? Those are x values, right? So what I have, guys, is I have two x values, right? If I have two x values, then I have two different points, right? So one of the x values is 1.5, and the other x value is 4. Now, in this example, I give you a chart, right? And that chart makes things easy to figure out the corresponding y values. Would you agree with that? Okay. If I gave you a function, right? If I said f of x equals 3x squared plus 5, then to get the y values, you would have to take those x values and what? Plug them into the function, right? Well, in this case, I give you it, right? So it makes it a little bit easier. So at 1.5 hours, somebody got a 62. At 4 hours, somebody got an 80. All right, so I want to find the average rate of change, and that is nothing more than finding a slope. All right, so I want to find a slope. Does everybody have a calculator at their desk? If you don't, make sure you have one, because I'm gonna show you guys how to do it with the calculator now, where I guarantee you nobody will ever get it wrong. Okay? So here's what I want to do. Let's get slope down. All right, let's make slope a slam dunk, okay? You can't ever get a slope or an average rate of change problem wrong ever again if we use the calculator to do it, okay? In fact, you don't even need to know the formula. So Isaiah, what I want to do is I want to get this on a graph. I want to graph these 2 points, and I quickly showed you guys this the other day. Some of you guys had seen it before, a lot of you had not. I want to do it together, okay? So the first thing we're going to do, always create a new document. Don't ever do anything, guys, in the scratch pad over here. All right, don't ever use these buttons, okay? They lack some of the features of the other side, okay? So we're going to go to a new document, and we're going to go to graph. When we go to graph, it wants me to enter an equation or some sort of function, right? We're not going to do that, so hit escape. And what it does is it gets rid of that. It gets rid of that entry line. Now go to menu. And what I want to do is plot points, right? Those 2 points that I just talked about, I want to get them on my grid. So the way we're going to do that is we're going to go down to geometry. We're going to ask the calculator to go to which option? Point. And we're going to choose option 1. Just pick option 1. Because it's not a point on something, it's a point, right? See how the little things on the side show you what it's going to do? Gives you a little picture of what it's going to do, right? All right, so go to point and click on that. When you get that, guys, you're going to get the little pencil that you can move around anywhere you want, right? Is anybody not with the little pencil? Are you sure? Okay. The problem with the little pencil, guys, is it relatively shows me where I can drop it, but I don't know exactly where it's going to drop it. So I want to tell the calculator exactly where to drop it. So to tell somebody where to drop a point, you have to tell them where the point is, correct? And what does a point start with? A parenthesis. So you're going to go over to a parenthesis, which is on the left-hand side about halfway down. And you're going to open up a parenthesis. And what happens is it's going to give you this little random point where you last put your pencil, right? So your point's going to be probably different than mine. And it's going to highlight the x value. So I want to put in the point 1.5 comma what? What is it? 1.5 comma 5? 4? 1.5, 4. All right, so I'm gonna type 1.5, enter. And it was 4, you guys said?
4 was the other x though.
All right, what was the y value of the 1.5? 16?
62.
62. Sorry. 1.5 comma 62, enter. All right. Now it's kind of hidden, guys, but it is right here, and it changes our scale so we can see it. Okay. So far so good. Now I want to enter the second point. Notice that the calculator still has a pencil here. Notice up in the left-hand corner, it still has a point here. It's still looking for me to enter points. So parenthesis. What was the other point? 4, enter, 80. Enter. And there's that second point now. What's the calculator looking for? Another point, but we're done entering points. Okay, so to be done doing whatever we're doing up in this corner, just hit escape, and now we're out. Okay, so we plotted the 2 points that we want to find the slope between, or the average rate of change between. Now what we have to do is this. Do you guys agree that 2 points don't create a slope? What creates the slope? The line that goes through those points, right? So now I got to go back to menu. I got to go back to geometry. I got to go back to points and lines. And now I don't want to use segment. Oh, I could use segment. I'm just going to use line. I'm going to use line. All right, so I'm going to go to line. And all I need to do now is it says up here, I want to graph a line, right? If you don't know what to do, watch this. Just move your little cursor up there, and it actually tells you. It says to create a line, click 2 points through which the line should pass through. Oh, okay, we have 2 points. There's one here. I'm gonna put the little cursor by it. See how the little hand comes on? And hit enter. And I'm gonna go to the other point and hit enter, and there's my line. And I know it's a little touchy, guys, so just be careful. Use a little pad, move it around. You'll eventually get it. But you got that point now, right? Or I'm sorry, you got that line now. Now what's it looking for? It's looking for another line. So how do we get out of that? Hit escape. What do I want to know about this line? I want to know the slope. So now I go to the same spot. I go to menu, and I go to geometry. And I want to know the measurement of the slope. So I go to measurement of the slope. And if I don't know what to do, it says click an object to measure. All right, well, the object we want to know is this. So I put the thing on there, and it gives me the solution of 7.2. All right. No doubt about it, the thought that probably going through about 3/4 of us is, well, that seems like an awful lot of work. It's easier just to do the slope. And I know it is, right? This is like that thing you're going to do when you got 3 hours or 2.5 hours that you got to sit there and there's nothing else to do at a Regents exam, right? I mean, you can go back and check some things, and this is one way to do it, all right? All right, so we have our slope. Our slope is 7.2. All right, and we can use our formula if we need to, but that's good enough for me. And it says, interpret its meaning. What does that mean? Well, this slope is represented by change in y over change in x, right? Well, the change in y was what? Score, so the number of points that you got on the test. And this is the number of hours, right? So do you guys agree that it's 7.2 points per hour, right? So what that means is for every hour spent studying, you got about 7.2 extra points. Everybody got that? All right. Use your calculator to find the equation of the linear regression. Oh boy. Okay. Well, linear regression. This goes all the way back to algebra class, or for some of you guys last year. Here's what I got to do. To create a regression, this data needs to go into my table. Okay. So I'm gonna create a new document. I always create new documents. All right. I don't ever use an old one. And I'm going to go to a list or a spreadsheet. Okay. And I always have to label these two columns. So in this case, I have an X and a Y. And make a note, guys, this second row never, ever has anything put into it. Okay. So we always bypass this. And now I just type in all my data. You guys are all typing away. So go ahead, type away. I was just going to say something nerdy. I was just going to say how hearing all you guys typing on the calculator is like music to a math teacher's ears, like click, 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 click. But I'm a little embarrassed to say that, so I won't. All right, guys, here's the common mistake. I'm about to show it to you, right? I guarantee you somebody's going to wind up with an error dim mismatch or something weird like that. And here's why. Do you guys, I just put the data in, right? You see my screen? You notice that last cell? What's in that last cell? Well, it's got like a little, it's looking for like more data, right? Okay, this cell isn't considered filled in until I go out of it, okay? And if you stay in there the way it just was, like right now it's okay because it's already filled in, right? But a second ago, if I tried to do what I was going to do next, it would have given me an error because it wouldn't have recognized any data in there. Okay, so just make sure that you enter that last piece. All right, we want to do a linear regression. We have a document opened, right? I want to add a page to my document. How do I add a page to my document? Control, which is this yellow button, and then the button up here, doc, right? And that will add a page. It looks like I created a whole new document. It just adds a page to this one. So I go to add a calculator. And we're looking to do a linear regression, right? So if we go back into our memory banks, we're going into that menu option, right? And a linear regression, guys, is actually a statistical calculation. So the area that I just went, guys, I want to show you that again. I went into the menu. I went into statistics, stat calculations, and I'm looking to do a linear regression. And there's two options for it, guys. I don't know why anybody would choose this one, right? I mean, that's kind of silly. Let's go into the one that we're a little more familiar with, linear regression. We're doing our linear regression on the list that we labeled as X and Y. The rest of the stuff, leave it. It okay? And we have a regression, right? Guys, what is a regression? Who can actually describe what a regression is? Exactly, I didn't think so. I mean, it's, you know, we know how to do it, like on the calculator, but we probably don't know exactly what it is. So if I was to create a new page, you guys don't have to do this. And if I went to data, here's a bunch of points, right? Right now, they're just haphazardly drawn on here. If I actually create an X, and a Y. It now takes that data and plots it, right? And do you guys agree that that data is almost linear? All right, it's almost linear, right? Why is it not exactly linear? Because all the points aren't on the same line, right? So what a linear regression does is it finds a line that represents the data best, right? So, and there's a lot of, and it's all like inner workings of how the calculator does that, guys, right? And if you take statistics with Mr. Unson someday, then he'll explain to you exactly how you get that line by hand. You're not responsible for that. But that line was, I think I can actually put this in here, regression, show linear. So there's that line of best fit, right? There's that line of best fit. So that's actually what you're doing. Is everybody okay with that? All right, wonderful. It says round to the nearest hundredth, okay? So that gives us a chance to practice that skill of rounding again. All right, so I have this. Can I take a pic? Oh, I know what I can do. Watch this. I'm kind of lazy, guys. I'm going to do. All right, so there's that. Of course, that's not rounded, right? So now we'll round it, and it says to the nearest hundredth. So that means I'm interested in that one and that one. So my first question, do I need to change this 9? No, because what's the number after it? 0. Do I need to change this 6? Yes, because what's the number after it? 9. Okay, so I have y equals 7.99x plus 51.17. All right, guys, then I have this phrase that says, give me the correlation coefficient. All right, well, to do that, we got to go back to this, right? We got to go back to this. Let me take a picture of that now. All right, so that's right here, right? And it says to find the correlation coefficient. So I heard somebody say it's R. Is it R or is it R squared? Right? So this is like one of those, you want to know the truth, guys? I don't remember. Bang! Now we're talking, right? So, and I mean, guys, this is like, this is like one of those moments where it's like, uh-oh, Carl don't remember what the correlation coefficient is. He knows it's either R or R squared. So I guess I have one of two options. I can write my old high school friends and tell them that my high school teacher sucked because I don't remember what the correlation coefficient is. Or, ready? Let's see here. Correlation coefficient on TI Inspire. All right. Let's see what this says. What do you mean, don't give you the answer? Should I ask Alexa? Oh, all right. Is it R or R squared? Find the linear the next step is to find the linear correlation coefficient, which is R. All right. Oh, look at this. And here's a nice little, this shows me exactly how to do, what? What? Linear correlation coefficient is the R value. All right. So So we're looking at that R value, guys, right? And it says to the nearest thousandth, right? 0.993, okay? Now, it says explain its meaning. What does that mean, correlation coefficient? What does that mean? Yeah, the closer that number is to 1 or -1, the better the line of fit, right? If the correlation coefficient is exactly 1, it means that the data was collinear. It means all the data fit perfectly. The further those points are, the worst, the what? Or the worse, sorry, not the worst, the worse the correlation coefficient. So if I did this to you guys, watch. If I skewed this data a little bit, so let's suppose the guy who studied for 1 hour got a 99, right? Must be nice, yeah. What's going to happen? Well, we're going to have this piece of data that's all the way up here now, right? It's an outlier. That's exactly right. But what happens? The data or the line gets way skewed, and the correlation coefficient, so I have to go back and redo this now. And the correlation coefficient goes what? Way down, right? So that will give me a pretty good approximation of whether or not that line makes sense or not, whether it's a good representation of the data. All right, so use your equation from part B to find the student's score if they studied for 3.5 hours. Well, guys, I have an equation up here. (7.99x) plus 51.17, right? So I got that. All I got to do is plug in 3.5, bless you. Right, so I'm just plugging in that piece of data, and what am I getting? What am I getting? 79, give me the original. 135. So this says answer to the nearest integer, so I have to round. Nearest integer means what? Whole number, right? So 79. All right. Last for today here. Yeah, it looks like there's a lot. We're gonna breeze here through this piece. So here's what we got. We got words. Uh-oh. A factory produces widgets. What's a widget? A doodad. All right. It's a thing. Yeah. So the cost to produce W widgets is given by this equation. So what does that mean? Well, it means for every widget that I create, I got to plug into this, and it's going to tell me what it's going to cost to create those widgets, right? So if I want 10 widgets, I plug 10 in, it tells me. If I want 100 widgets, I plug it in, and it tells me. Each widget sells for 26 cents. Thus, the revenue gained is 0.26 times W. Guys, what does that mean? It means for every widget sold, I bring in 26 cents. So if I sell 2 widgets, I multiply 0.26 times 2, right? Use your graphing calculator and label each of these linear functions for the interval 0 to 500. Ooh, wow, interval. New document. Add a graph. And here's what we got. We got our first domain restriction. That was funny. We have our first domain restriction. Guys, if I go back to this piece right here is really, really important. Do you guys agree that both the revenue and the cost, what's revenue? What's revenue? Money that you bring in. What's cost? Money that you put out. So in other words, if you run a restaurant, your cost is what? It's the food, it's the employees, it's your rent, it's your RG&E bill, right? All that stuff goes into your cost, correct? All right. Your revenue is what? The money that people give you when they what? When they eat your food, right? As a restaurant, that's how you're bringing in money, right? The people that give you money for your service. So, what is the driving factor? What is the driving factor in determining the revenue? Well, the number of meals that are served, right, in a restaurant. Well, here it's the number of widgets that are produced or sold, right? So W is really the input value. So W serves as like an X. So X is like the W, and Y is like the cost. So just be aware of that. It's important to have an idea of which goes where and what's the input and what's the output, right? So Y is the C or the R, right? The output's either going to be the cost or the revenue, depending on because we're going to have two graphs here. We're going to have one for cost, one for revenue. All right. So it says I only want to look at the case where I sell no widgets at all, or I sell 500, right? So I want to look at what happens in this domain, right? So if I'm talking about domain, I'm going to call this my X, which is my number of widgets, right? So I'm calling it an X, but in this particular case, it's really a W. And then this is going to be a Y, or it's either going to be cost or revenue. So I have cost or revenue on the y-axis. I have number of widgets on the x-axis. And here's the thing that I know for sure. I'm only analyzing this up to 500 widgets, right? So let's go up to 5. Now, guys, I got this nice big grid, right? Like I don't want to make this like, oh, good, here's an idea. 100, 200, 300, 400, 500. I mean, that's kind of silly, right? We're not going to do that. So 1, 2, 3, 4. So maybe that's 100. So maybe we're jumping by 25s. 1, 2, 3. So here's 200. All right, so that's pretty good. That'll work. Can I put a scale on this yet for the Y's? Because I don't know what my revenue is. I don't know what my cost is, right? So this is where I'm going to use a calculator now to help me do that. Do me a favor, just push your pencils down. Just hang out for a minute, okay? Just watch. We'll finish. I'll give you time. We'll finish this next class. So, I just want to show you what this looks like, okay? So here's what I have. I have the 0.26W, which I said instead of W, we're going to use X, right? This one represents the what? Which variable was that for? That was for the revenue? All right, and then what was the other? It was 0.18W plus what? 20.64. All right, so 64. All right, so I have that, right? Now here's the thing. I only see one of them. I don't even see the other one. But remember, that's because we have a domain restriction, right? So the way to handle that in your calculator is you're going to be going to menu and you're going to be going to window and changing your window settings, right? Window settings is basically how much screen do I see and what does that screen focus on, the grid, right? So I want to go to a minimum value of 0 to a maximum value of 500. Now, guys, here's my word of advice. Don't ever change these. Once you change these, it'll do that. And that seems wonderful, but I still don't see my graph, do I? What you're going to do is you're always going to go to a zoom what? Oh, good. See, I'm glad you guys don't know this. You're going to go to a zoom fit. And what a zoom fit does is this. A zoom fit will never change your x's. It will only change the y's. So when you tell the calculator, I want to look at this x value, right? It's going to say, okay, I'm going to do that. And then I see zoom fit. It's going to say, okay, within this value, I'll show you the picture now. Okay. So now if I go down to my zoom fit, watch, it's not going to change the width, but it will show me my graph, and it shows it nicely, doesn't it? Okay. And that's a really great feature of the calculator. So I only change x's, and then I use zoom fit to show me the y's. Now what's really nice about this, guys, is it also changes my scale. So how high do I want to be able to see? 143, right? So we'll go up to maybe 150. So we'll go 10, we'll go 20, we'll go 30, 40, there's my 50, 60, 70, 80, 90, there's my 100, 110, 120, 130, 140, 150. So it really does a nice job for us, right? And then we can create our sketch. And we can create our sketch. All right, why don't you guys take the night off? Don't do anything homework-wise, okay? Tomorrow we'll finish this up, finally.